Okay, so in this video, I'm going to do a tutorial on this small 7x7 seamless cave door. I built it yesterday, 17th of September. So it's 1,170 blocks, 13 by 15 by 6, and it's currently the smallest. So yeah, it's 6 wide instead of 7. Well, I just added this layer, so it appears to be 7, but it's only 6 wide. So beating the previous record by 300 blocks. So I shaved a layer from the top and a layer from the width. So pretty cool. And I also did a tutorial only in another video. So if you only want to know how to build this door, then you should check that video out instead of this one. But if you want to learn some of the concepts behind this door and maybe some redstone skills, then this video is for you. So enjoy. And without further ado, let's get straight into the tutorial and the explanation. So here are the stuff you need for this door, quite a lot. And let me just give a bit of context for you. So I didn't include the items in the container blocks, and also I didn't include the water bucket for the cauldron, so you need to. So you need 4 snowballs or items that stack up to 16, and some more items that stack up to 64 standard items. Yep, just a couple of them. So just prepare that. And yep, this build uses minecarts. If anyone that doesn't love or doesn't like minecarts, then I'm sorry. This build does have 2 minecarts, not that much. So these rails and oak fence are just temporary because you need to place the minecarts. And yep, they're not included in the build, but yep, they're just for the building process. And so you need them. And yeah, so you can take a screenshot or pause the video to see for yourself for the resources if you need them, need the list. Okay, so for the dimensions, the length is 15, the height is 13, so 3 blocks for each side. You can see 3 blocks, and 2 blocks for the top and the bottom. 2, you can see, and 2. The width is 6, as mentioned before. Yeah. So for this tutorial and explanation, I'm also going to do color coding. I find that a bit fun, and also I can explain stuff clearly, and you can see the circuits clearly as well. Oh, no, don't do that. Servers, okay. So we're going to start off with the layout. The layout is a bit complicated actually, but I'm going to go straight into it. So the bottom, you want a V-shape thingy, basically. So 5 pistons in a V-shape. Those are singles, and the doubles as well. 5 of them, and yeah, again a V-shape. Okay, so and you would need some more. So this is more like the 6x6 cave door that I built with slime blocks. And instead of doing like this, I do have the opportunity to do this. Instead of doing this, I didn't really choose this because later you'll see why I didn't choose this approach. So yeah, we're going to do the exact same thing as the 6x6k door with slime blocks, which is the folded double for the flush pistons. Same for the other side. And also this will also be used at the top. So yeah, the top has similar reasons. Yeah, actually I don't really know, but yeah, I just choose to use folded double for the top because giving pressure to the side isn't that good in my opinion. So yeah, I choose to do with the top. So since we only have 2 high for the bottom, we will need a folded triple, and the layout is quite simple, just this. So a sticky piston here, observer facing upwards, yeah, and that's it. That's the folded triple layout. For sides, size is probably the most complicated one, so be careful. So we want 3 triples, again in a V shape, but just 3. So already you see a problem. This bottom triple, you don't really have space to power it, and that's why we're going to have a piston with an observer here. Yeah, basically that. But we are not going to have this observer here because we're going to do more stuff later, and the layout isn't really that, and you'll see why again. So 3 doubles in a V shape again, and then 3 singles again in a V shape. Sorry, you can see the sides are actually quite a pressure, quite a challenge actually. So we do need to deal with that. And the reason why I said we don't have this observer here, because the observer is actually here. If I can place that, the observer is actually here, and this instead is an observer facing upwards, because we still have to power this, basically. Yep. Also, this observer is here because we need to power the double retraction. Yep. And the reason why we have this piston is because we are going to place a piston here and an observer. The reason is quite simple. It's because we need to have the retraction for this double, and we don't really have space because this here will be reserved, so we don't get to use that. So we are going to use sliders. So it looks quite weird for this configuration, but it isn't that bad. Quite manageable, in fact. So yeah, this is the side layout, I think. Well, actually a bit more. 3 singles here. So this one, it won't be here because powering this is not the best thing. Well, actually, I do have space, but I choose not to do that because if I can do it at the top and it's convenient, then why not? So it's convenient to do it at the top than to do it at the side. You need to have extra lines to power this piston only. And yeah, if I can do it at the top, then I guess doing it at the top will be better than doing it at the side. So we're going to copy the exact same thing for the other side, and also make sure to place these blocks. It will be quite bad because these blocks have to be solid. So same thing, 3 triples in a V shape. I'm just going to place this triple thingy like here because just to place those pistons. 3 doubles, singles, all in a V shape. Looks pretty cool. And we're going to have this normal piston with an observer. This normal piston, this normal piston, this normal piston. Yep. Observer here, observer here. And that's basically our side layout. Well, 3 more pistons. I always forgot those because why not? Forgetting things. Yeah. Also, if you're wondering why this piston is here, just because we need this to like push out. So this is quite simple. And now we're going to go to the top. The top is quite similar to the bottom, actually, again, except with minor changes. So we're going to start out again with a V shape single extender pattern, 5 single extenders. In fact, there's actually 7 because we still need these 2. So, yep, there you go. And 5 doubles in a V shape. Again, I'm just going to remove these blocks so I don't have a hard time placing those pistons. There we go. And now you want to place those blocks back. Right. So again, the top is only 2 high. Technically 3 because this block counts, but whatever. So again, you need folded. So a folded triple is going to be just like this. On a folded quad, now the folded quad is basically the same as triple, but we do need this piston and an observer just to power the piston at the lowest point. This here. We need the observer to go to this level at least. So there you go. Oh, of course, don't miss out this one, the folded double for the flush piston. Okay, so I think that's the layout done. If I miss out something, then I guess I'll add that later. So now we're going to start on the input. So red wool, as per usual, and actually obsidian. We're going to have obsidian for the input already. Quite peculiar. So the obsidian is placed here. This is to accommodate for this bottom for the double, because later you'll see some issues with that. These 3 blocks are the input blocks basically, so it's a repeat input. Yep, because you can redirect this dust. Also, this door is 1.11 plus. If I didn't reset that hit there, so no blocks at all. Right. Actually, I do have those items here, so might as well use that. Oh, I don't really need these now. So the bottom, I'm going to color code it as orange. You know, because quite standard. Color coding bottom of orange. I don't really know, but yeah, I don't really do color coding, so yeah. We're going to take an output from this piston, just through here. Simple enough. And get yourself some transmitters and conductors, namely hoppers and droppers. We're not going to use no blocks, so yeah, those are going to be the ones. 2 observers here and a hopper, same thing. Okay, so we got this lovely thing here, and what we're going to do first, yeah, let's do the double and some pulses for here. So let me just explain how this works first, because I am more afraid that some people don't know how this works. So, and let me also explain why we need a rest block. Jeez, a rest block. I mean, an immovable block. Sorry. Yep. Why we need an immovable block here? Okay, so what you need to know is how the sequence works. So oops, sorry. I think that I already explained it in my 6x6 cave with slime blocks tutorial, but for anyone who haven't watched it yet, then I guess I'm going to explain it. So first off, this gets pulled, so yeah, this piston can now push up. So we're going to power this, and we're going to power this vortex here. Now, ordinarily, this dust is locational, because when the piston goes here, this dust can either power the top one or the bottom one. But it isn't like that in this case. This is due to a thing called race condition, I think. I didn't research it up, but yeah. I didn't search for the name, but yeah, I think it's called race condition, which basically means that when the pistons are pushing like this, and it will always power the top one before the bottom one. So it's similar concepts to budding pistons, like doing piston stacks. Like if you were to have this here, and instead of just powering this twice, because this is pulse fast enough, and it would basically pull this bottom piston and power the bottom piston. So, yeah. So if we were to see this in action, you can see the bottom piston powers instead of the top one. If we just leave it like this, then the top will actually power it twice. But due to race condition, if this were to be a piston, then yeah, the bottom will power. So it's basically the same thing as here. The piston just got pushed over to here. Same thing as the piston got pulled just now. And the priority is that this piston is going to power first before this gets to power. So actually if we have this here and power the vortex, it won't work. But if we have this here, then it would work. So we can see that in action. So basically this here pushes, goes here, this powers, push this piston to here, pulls back, this piston powers. This is for the retraction, like when the piston goes from like the piston goes from here to here. The last pulse will retract it. Basically that. And yeah, so we were to see it again, this pulse will basically pull that. Oh, well. So, and after that we're going to close this off, because we're basically this is like a sequence. So we're going to close this off, and this will power. And this is the thing that's different. You can see this piston also powers, and it doesn't really matter actually. To the reason why this piston has to power, the reason is that before this goes out, I actually have another version of this door, but later I discovered that the door is directional. The reason for that is this. So if you can see, this is actually north-south for this configuration, though this looks like it's east-west, but because the door is facing this way basically, so it's basically north south for the door. And I was building for the north south and I didn't realize this. So basically, when this piston retracts, oh no, not breaking the repeater, you can see this piston gets spotted, and it does a 1.5 tick pulse, I think, or at least longer than 1 tick pulse. So yeah. Now, ordinarily, this is fine. Yeah, but what happens when you place the door in east-west direction is that this piston gets spotted as well, and the directionality implies that this will power first before this one, and you can see it like this. And this cannot happen, basically. If this happens, then the door will fail, the door will break, and yep, it just doesn't work. So at the end, I just need a fix for this directionality. So I bet. But yeah, anyways, that's more of history. So you can see that ordinarily this won't power, but due to the fact that I have this issue and I really need this observer because I can't place it anywhere to power this piston. So, which means that I need to fit in another observer, like another tick, and I'm not going to have the tick unless I do it like this. It powers the bottom piston, but it's fine. Literally, it's fine. So you can see it just retracts, and then we can just do the exact same thing. This a pulse here, nothing happens, and then this pulse here. Yeah, and we can close it off. And when closing it off, this obsidian is blocking this piston from powering. Yeah, that's how we get this to work. So it's basically a sequence: unpower, power this one, repower this one. Same thing for the opening and the closing. And that's how these doors work basically. You just have everything powering both the closing and the opening, and yeah. So we've learned how this thing can work, how it can work. So we're going to connect it now. But first we're going to do the double first, or actually maybe not. We'll see. It depends on my memory actually. So yeah, I'm actually going to do this pulse first. So we're going to ignore this yet for first because this is related to the slider, and the slider we're going to build later. So yeah, basically the bottom needs the side to help, also needs the top to help, essentially. Yeah. Anyways, so we're going to have this. So this is for the left side only. You don't have to build this for the right side because the right side will be slightly different. So. Yeah. Yeah. Okay. So before I forget, I mean, I'm going to place this 2-tick. We'll use that later. So this does and this does, and we want a 4-tick repeater, and it's going to run to a dropper, and running into this here. Now, this is one of another cool thing you can learn. This is basically called a budding dropper double. I call it, at least, because you literally bud the dropper, update it, and yeah, it will work. So by budding the dropper, it actually gives this 1-tick pulse 1 tick later, I think, as I analyze it. So this basically behaves like a standard double. You just have to butt the dropper and it works. It's quite neat. So you just make it in conjunction with a vortic and it will work. Just don't have anything update this dropper. And we're not going to have this dropper here because we're going to do it at the other side, and also this dropper will get updated, and that's why we can't have it even. We are just going to do it from the other side. The other side, the dropper doesn't get updated, so we can do that. Yeah. Okay. So back to here. We're going to do part of the slider. Actually, only very few. So, yeah, this observer is going to power this vortic, and it will work later. It just doesn't seem right because it doesn't, of course. Haven't built the full slider yet, and the reason why is that we need a resting block here. And I'll explain how it works after I placed these, a dust and a 2-tick. And yeah, the 2-tick is actually in the circuits. And these two observers are also in the circuit. So allow me to explain why would this thing work. Let me just actually do this because I don't want it to power. Okay, what you need to know is that this resting block is basically butting this piston. And when this observer is going to power this hopper, not only does it power the hopper, but also it updates this piston. And if you only update it once, then it will do a 1.5 tick pulse, I think, or at least not 1 tick pulse. It won't speed out the block. But notice that observers give 2 updates, essentially. Like basic observers, when the observer powers, it gives an update, and after 1 tick, it turns off, and it gives another updates. Essentially, it will just make this piston 1 tick, and it will speed out the observer. But we want this vortic to power, so we just have this 2 tick to track it back. Yeah, that's a brief explanation. And this resting block is just responsible for this 2 tick to power. And yeah, the slider will get pushed down. This is literally a slider. We will build the rest of the slider later. And yeah, we have explained this concept. And since this is powered twice, it doesn't matter. The closing doesn't matter. It gets constantly powered. The opening also doesn't matter. It just derps out and derps back. Yeah. So now we're going to do the same thing for the other side, except we power this pulse with a different way, because yep, let me see, because I do sometimes forget how to do a circuit and I have to think a bit. Sorry about that. So we're going to have again 7 ticks because there is 7 ticks there. Well, we replace these white stained glass. There we go. Right. And a hopper here. So yeah, this is 7 ticks. And before you place the observer, you want to place this dust first. There you go. So, and again a vortic. Also, for versions before 1.16, you want to place the vortic first before you place this observer. Yeah, just a bit of context. So again, a 2-tick. We explained that bit already, because this is literally the same. vortex, dust, observer, remove that, block, dust, block, 2 tick. Also 2 ticks just for the timing, because the sides are powered in such a way that this has to be a 2 tick. So I'm not going to explain too much on that, because that's just timings, and these are really impressive timings. All you need to know is it does the job. So, yeah, you guessed it. We have these 2 budding droppers, or budding droppers, I mean. And yep, this vortex powers these 2 droppers, powers these, and yep, the same timing as this, so the budding won't get affected. Yep, the reason why we can't have this here the same as this one is because we have this dust here. I always wonder why, but yeah, now we know. Anyways, we're going to finish the bottom by adding the triple. So yeah, this is a hopper ROM, and why would you use a hopper ROM then, though? And that leads to the explanation of this. So this is basically the bare bones of this triple. I'm sorry, this is a bit messy, but you can see these triples are located like this. Yeah. So let me introduce you to the sequence. Actually, this door has quite a lot of extenders, and some of the extenders do require sequences. The bottom triple, folded triple, is one of them. So you can see here some thingies, and you know. Okay. So this is power input A. Input B is here, this observer. Input C, literally this piston. Input D, this observer to this redstone lamp, or a piston head. No, piston body. Redstone lamp works the best actually, so I use a redstone lamp at the end. Okay, so this obsidian is also important for a reason. So we're just going to power this sequence entirely. Well, except for this one for one iteration. So there are 2 iterations. One is to power the C, another one is without the C. You see what I mean. So, okay, so we're going to have A first, and this is the reason why we have an obsidian there, because A is going to power, this is going to push. If there's no obsidian here, this will break. So A, literally nothing. Well, actually this piston firing, but it doesn't really matter. And then B is right here. We power B. So you can see it's like this. Then input C, the first iteration, we want C to power. And D. This is a double pulse, so it was just basically extend and retract. So you can see it does the extension. And the C long pulse will also do power. So yeah. Now we're going to repeat the same thing again without the C. So A. So you can see this circuit is actually taken from here. Literally. Taken from this vortex. The concept of it, I mean. So it's literally the same. So we have A vortex powered, and you can see it retracts like this, and we don't really want that because we still need to retract this. So B, and we're going to skip C, we're not going to power it, and we're just going to do D, and you can see it is completely retracted. The extension works exactly the same. I can show you. A, that's nothing. B, C, D, C empowers, A, B, D. There we go. So, in conclusion, we have two iterations, one with the C, one without the C. And this is great news. Basically, all we need to do is to just link up these four pulses or signals. And once we link them up, we just use a hopper ROM and to power twice. And that's why there's a hopper ROM there. And there is no hopper ROM here. The reason is that it's actually linked already from this side, so we don't even need a hopper ROM there. And the items for this is quite special. This is this 16 stackable items that come in handy. So you want 4 items stack up to 60 and 7 normal items. The reason for that is because of the side. You can actually have 6 snowballs, it will work, but with the sides will actually interrupt the bottom a bit, and to avoid the disturbance or the disturb from the sides, whatever, we are going to just delay the bottom a bit, and it will work. So yeah, capacitor, dust, you guessed it, observer, block, 4 tick, and we're going to part this. So this is A, and before that, we're going to also part this. And now we're going to enter a very interesting circuit. So opposite this dropper, observer, block. We're going to have an updater here. But we're not only having an updater there. We're going to have something even more special. That is just to power this here. And you might think that this is okay, but it's not. We actually have this piston as well, in conjunction with this observer. And we're actually going to obsidian. We're actually going to block these off. And this is quite specific. So hopper here. So this is literally input B. Okay, so let me explain why this happens. So it is more of a timing. So if you don't have this piston, it would actually not work. And I can actually test it now, I guess. Doesn't really matter now. Now you see it works like this, but I think in the second iteration it doesn't work. Yeah, let me just try it in the second iteration, because this is the second iteration. Let's work though. Well, I don't know, but it might be, yeah, I don't really know, but just have this piston. Maybe in the actual door it doesn't work, but yeah, I don't know how to explain that, but in the actual door this is used. I might test it without the piston, and yeah, I'll see. But for now, this is safer. Yes, I do have occasions to see this not working. due to a few reasons. But yeah, whatever. Maybe it's my mistake, maybe not. So observer there, block piston here, and now we're going to have the dropper circuit. This is quite neat. So the observer is here, and we're going to have 4 droppers going anti-clockwise. So this, no, this, and this item in this dropper, and we are going to have the compressor here. Yeah. So this is basically a very simple 4 cycles total. So this is going to power 4 times because well, we're going to later have this pulse here. So you'll see. So first time, actually I should remove that. This first time, this is going to power. Second time, this is going to unpower. Third time, it's going to do nothing. Fourth time, it's also going to do nothing. That's exactly what we wanted. Yeah. So if you want an explanation for how this dropper loop works, basically when this piston retracts to here, this item from here will go to here, and the powering priority is this dropper and these two. So this is going to only go to here, but not going to skip this to here. So it's only going to here. So that's going to power it. Second time, this here goes to here, this block, the observer below. So this item will go from here because this powers this dropper and this dropper, which does nothing, and also powers this dropper, which pushes the item from this here to this here. So that's the second pulse. Third pulse, the observer will retract, so it's below this block, this dropper. So it powers this dropper, does nothing. Powers this dropper, does nothing. It's like the second pulse. This, and it also powers this dropper, pushes the item from this here to this here. The fourth time, the dropper goes back to this location, and yep, dropper powering priority. So it's going to power this dropper and then this dropper and this dropper. So the item will go from this dropper to this dropper, and it's not skipping. So it basically goes back to its original destination, original place, whatever. So that's a brief explanation. Hopefully you will understand it. And we're going to make use of this here. So this observer is going to retract for the first time, and it will also retract for the third time because we're going to power this, and it's going to have 2 more pulses. So we're going to make use of this and place an observer here, literally, and then rest on that. 3 more observers. And let's see if this is going to work. Well, turns out it's going to work. Yep. I think. But for sake, I'm just going to add this back. So I think you can remove these 2 pistons, but yeah. I'm being stubborn, and I will just place these 2 pistons back. Yeah. I think you can remove them, but this is safe, I guess. Okay, so this is done, and and I've also explained how this works. And the bottom is basically done for now. Yeah, we still have to complete the slider, of course, but this will be the job for the sides and the top. The top is going to push down the slider. Well, the side is going to part the top, and some parts of the top is going to part the side again and push the slider back down. And you'll see later. Yeah. Now let's move on to the sides. Enough rambling and enough talk about that. So we're going to start off with 4 yellow stained glass. So those sides stained glass are actually yellow. I just didn't color code them because I'm lazy. So yellow stained glass, and now it's going to be the cauldron. 2 cauldrons here. Fill them with water. Oh, okay. And server on top. And it will make sense later. And for those people, like they would realize what's going to happen later. Why we're going to have this here. I think some people already realize it, but let's see. So I'm going to build something right here first. If you don't understand it, don't worry. We'll cover those later. Oh, no. Replace that. So, checkerboard, shape thingy. Replace that. Before I forget thingy, so I'm going to add something. So, this dropper is needed. And also this dropper. So these are basically self-explanatory. Yeah. Why do we need these droppers, you may ask? It's quite simple, because this dropper is going to get buttered and powered. And because this is essentially a long pulse, and this double would extend, and then the piston would also extend. So yeah. Do we have to worry about the retraction? No, we don't, because this pulse is going to get it. Some pistons, we can't get them because, so yeah, we're going to have this piston just to push down this observer to get this piston to retract. And this will derp, you've seen it there. But yeah, this will derp, but it's fine. It's just extra 2 pulses. So, yeah. So the top 2 triples are quite easy, because some of you might guess it already if you're familiar with redstone. It's the standard one. Extremely standard. Nothing has changed. But this here, something has changed. Well, it's just literally a change of 2 blocks. So instead of having a block and a 2 tick, we're going to have 2 observers for later. Like so. Cool. And this also explains why we need a cauldron here, because this needs at least a 10 tick pulse. And yeah, having this would basically bring a huge convenience to the sides. And this is actually the only way we can get it. Yep. So Yeah, we also explain why this is. This is for the falling edge because we do need to care for this retraction. And yeah. Also, yeah, another reason for this is but yeah, it's actually length. Okay, so we're now going to go to the top a bit, and then we're going to go back to the sides. But before that, I want to add some things that I will always forget, and that's how to do the retraction for this. The retraction for this is quite simple. Hopper and an observer. Yeah. Same thing for here. Hopper and an observer. It'll make sense why it's hopper later. Well, actually, doesn't necessarily have to be one, I think. I don't know, but hopper is just more safer. Again. So we're going to go to the top. So, this is going to power for at least a 10 tick pulse, and we're going to make use of that to power this piston. Fair enough, because we do want this to retract and then extend a couple of ticks, maybe 10s, 20, whatever, just a long pulse, or I mean long delay. So yeah, we're going to just do that because that's convenient. Oh, and I forgot to do this side. We're going to do that now. I'm sorry. So yeah, just let me finish my jump. 2 tick. Oh, no. Oh, come on. There we go. There we go. I'm sorry, I actually can just place a ribbon. But I guess no. Same thing. There we go. So, same thing. And do it like this. And now we're going to do parts of the top. Basically this here. So, I don't know if I've explained it. I don't think so. It's basically literally the same thing as the bottom. So this powers and then this powers. And the same thing happens here, race condition. This gets pushed, this just gets pushed, and this has a higher priority to power than the piston on top. So, yeah, literally, it's the same thing. Yeah. So this is the concept. So we're going to power this first, and then we're going to power this. But we're going to ignore this first because we need to do the sides. So these are related. This is going to power the sides back. Good. Now the more important thing is to link to the top and then link back to the side. And yep, you guessed it. So yep, this is going to do the 40 pulse thing. Okay. Yeah, correct. And we're going to do this. No, don't place observers everywhere. Photic. Observer, hopper, observer. There we go. Cool. So now we have our way to our sides now. Slab. Slab, that's fine. That's why this also needs to be. Yep. Yep, that's why it needs to be a hole. Yeah, it actually explains it now. So this will push back down. And this faucet will power this piston. And yeah, just delay, nothing much that can be explained. Same thing for here. Yep. There's a big gap here. I think it's yeah, we actually fill some of those with blocks, but yeah, not now. And this is the top of the side finished, I think. Now we're going to get the side to fill up this rest of the space. We basically left out the space just for the side. We're going to start out by having trap chests, because I love trap chests to redirect redstone. Oh, so that's here, just to continue. Same thing for the other side. That's here to continue. Trap chest, no, trap, come on, there we go. And the reason why we need to redirect this redstone dust is because we are going to have the dropper circuit. It's just basically an arsenal lash. And I also forgot to place this piston somehow. Okay. Place an item in there. Come right here. You guessed it. Same thing. Bottom dropper gets. Oh, this here must be a slab. Go. Right. Now we are going to, because this here needs support, we're basically just going to do this because the rest of these are done already. Oh, also, if you didn't notice, this basically does the job for this double, if you don't know. So for the other doubles, they just get button from the triple, and the triple also updates for the double to have the double fired. So that's the convenience. Yep. Anyway, so now we're going to focus on this here. And I want to show you a circuit first, and like how we're going to implement that. So it's going to be this circuit here. Now, this is just a basic layout. So what happens is that I'm not going to simulate this because retracting this is a pain, and I don't want to automate that because I've automated it right there. So imagine this observer is here, and then this freezer will fire it, and then this piston retracts. So just imagine that. I'm not going to do it now. So this thingy here is the basic concept of how we are going to retract this. So yeah, you can see that it does a double thingy. Yeah, and we're going to push this back and to power this. And now we're going to do the exact same thing again, and this here would not power again because yep, T flip-flops. And yep, that is literally the thing, the sequence, or you can say. So you can see that we're going to power this twice, and in fact a small demo here already. So this is a bit different. This is 4 tick and 3 observers, and this is and it causes a difference actually. Let's reset this. Okay. So yeah. So the rest of the sides would power this here. This really does nothing. And then after it retracts, this will fire. So you can see it's quite fast. Don't know if you can catch that. But basically we're just going to use this concept. I think it lags a bit there, but whatever. So yeah, you can see that this observer gets pushed out, and then it gets pulled back, and then it goes down. And this circuit here basically controls the rest of the stuff. So we're going to always power this piston, no matter what. And the only thing we need to determine is whether this motor gets to power. And if it gets to power, it retracts this piston. And also it will power this thing, which will basically power this here. And we'll also reset for the slider such that when this push over, this can power the last traction here. Yeah. So basically we need to run 2 pulses, and there's a smart way to do it, and you can see it like this. This is directly linked, and all we need is just a few amount of the delay, and the delay is quite important because the delay also means for the delay for the 2 pulses for this thing here. So yeah. So the delay is here for a reason, and yeah, this is just timing. The 2 tick is the timing. The times when this has to retract. Yeah, you can see it works quite well. And this is also the actual circuitry, by the way. So yeah, we're going to build that now. Enough talking. So for this side, we're going to have a 2 tick here, and go to here. You guessed it, because it's literally from the circuit I've showed before. Just now, I mean. 4 tick here. This. And before I forget, again, I always forget these stuff. You want this to power this piston. And thinking that I don't know why that worked, but it works again. So, and we're going to build the rest of the sides. So, just gets reused. And reusing is one of the ways to compact redstone. So we're going to have this 1 tick here. Come on, there we go. And we're going to have this 4 tick, because minimum amount of the pulse length for this to extend, and then have that double extend, and then piston here, and power this. And you might be wondering, it also powers at the start, and you'll be right, but it doesn't matter. we have to wire it anyways. With that being said, I think this side is done. Let me just complete the other side. In place, and due to the dust being here, we can have that observer right there. So instead, the solution is quite simple. Just a drop here, and it works. You don't even need that to be a solid block. So yeah. To take and no, I forgot something. Ah, there we go. Yep. Now we're going to build the rest of them. Oh, oh. Luckily, uh, yep. Uh-oh. Oh, because this, basically gets spotted, and yep, this gets spotted, and it just extends and doesn't retract. That's a nightmare. I don't know why, but yeah, whatever. So, yep, basically this is the sides completely done. And now we can head to the top, and which we already done top a bit. And yeah, uh, and now yeah, more explanation, I guess. So the top has quite a lot of tricks, and those tricks are quite important. It's quite important to how the door works. So first, we're going to have something quite unusual, a rail. This is also going to act as an updater. This here would be a dropper because it doesn't have to be an updater. Now we're going to do this. So this is going to, you guessed it, fire these, and it also fires this one, which is useful. And also this is the reason why we just have this piston here. It's just convenient enough. And we're going to link it to a very weird thing, which is a zero tick generator. And why are we going to do this? And the reason for that is because we are doing wireless redstone. And yeah, we're just using glass panes. And why would you use glass panes? Because for compactness, we can't afford to have another circuit going around just to power the doubles. So using glass panes would be the best option. But then you would need to know that you would need to know the properties of glass panes. So ordinarily, a one tick, I haven't had something. Ordinarily, a one tick, if you can see here, you can see it does 2 pulses, and that's not what we want. Well, actually, let me just remove this. Yeah, it does 2 pulses, and that's not what we want. And but that doesn't mean that we can't use glass panes. We can just zero tick it. If we zero tick it, it will only give 1 pulse, like so. And that is a key feature, and that also makes that's also essentially how the double works. And all you need to do is to fire a double pulse fast enough to retract all of those. It's basically the same thing as my let me think. Yep, it's the same thing as my 6x6 cave without slime blocks this time. So the double, you can see the singles get derped, and the reason for that is just to power the double. Yeah, but instead we're going to use glass panes. We're going to be smarter this time. So, it's quite cool. But this also means that we can't have the singles to be in sync. And this is also the reason why we're going to have this. Because we are going to have this thing here. So 3 pulses, no, not 3 pulses, 3 ticks, and yep, this here. And we're going to take an output from this piston and do this. So this is what basically retract the pistons. And of course this is with a delay, and that's why these pistons, the left side and the right side, are powered at different timings, which is not that good, but you know, it's acceptable, and most importantly, the door works. So yeah, I originally wanted it to be in sync, but later I just think that this is convenient enough, and I don't really care. So yeah, and essentially we have already done the the doubles and the singles. Nice. And we are going to do the triple now. The triple is well, a folded triple, and let me also introduce you to a mini sequence. This is not really a sequence. This is just how we're going to power it. One of the hard things that people don't get is how to power a folded triple when there is a dust here. And the answer is we actually power it using a special delay. Extremely special, actually. And remember the fact that abusing, we're using race condition thingies to power this here and to power this here. And yes, we are also going to use the race condition to power this triple. Now, for simplification, this is literally this here, and this thingy here, photic observer, photic lamp observer. This is the basic idea, but I think what is more interesting is how it works. Uh, so this here, this here, and what you need to know is that the lamp actually turns on instantly, but it only turns off after 2 ticks. So yep, this basically gives a delay for the falling edge. So this is just a model, so don't worry. It isn't used in the actual thing for this time because uh, getting a lamp there is actually very hard, and it's actually better to just add a separate pulse than to do it with a lamp. So okay, back to the explanation. So uh, on the rising edge, this is going to power as well as this. So what happens is that this is going to power, and also this here. But this is also going to power, and yeah, raise condition again. Oh, sorry, my mouse loves to freak out sometimes. Okay, so this here gets powered. It basically one ticks. Oh, no, 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 no. There we go. One tick. So one tick, so it also busts this piston. And this is how we get the one tick, by the way. And this here is going to fire this here. So let's just suppose that it retracts. It's not the same. So it retracts, and the this is a 4 tick, and the second pulse is actually timed just perfectly for this to power. And this is the race condition thing. Basically, this piston just get retracted from this location to this location, and the second pulse powers just in time such that this powers instead of the top one. And that's how you get it, basically. And the lamp, yep, guess it, the falling edge. The falling edge needs just a tiny bit of delay, and it will work. Basically, just this retract. Like this, and that's why we have our sequence. And yeah, and that's how the folded triple works, for anyone who doesn't know. So perfect timings are one of the key things to making small doors, actually. Because of those perfect timings, you can save some space by just not having that many power lines, essentially. Yeah. Also note that this falling edge, you just power the falling edge at any time. So it doesn't have to be fast, it doesn't have to be slow, it just needs to be powered with just a slight delay. And yeah, it will work. Just don't power it directly. Yeah, back to here. And the way we're going to get this here is quite strange. So we're going to do this part first. So place it thus here. I'm so sorry, my mouse always freak out. We're going to place this thus here. Sticky piston, observer. Now notice that this here is going to fire twice. So it's basically a rising edge is going to fire this here. And you guessed it, piston and observer here. So this is going to be part of the rising edge. And at the falling edge though, it's going to power this hopper, right? So we're going to have this 4 tick here, literally, just to power it. And yeah, we need to basically time the other side such that it is powering exactly the same time as the rising edge of the 4 tick. So, how to count ticks? It's quite simple. This here needs 1 tick to retract, and after it retracts, yeah. Okay. So this here, because this is an observer pulse, it needs an observer pulse is 1 tick, so the piston needs 1 tick to retract, and when you retract an observer, you need 2 ticks to power. So this thing here is 3 ticks, 4, and then adding 4 more, that's 8, 9 ticks. So we're going to power this 9 at the exact same incident. 1, 2, 3, 4, 4. Sorry, 5, 6, 7, 8, 9. And that's how we power it. Cool. Now, you do need to notice one thing again, is that this is going to power twice. Once the rising edge, once the falling edge. So what this would basically do is, for the rising edge, actually this is dual edge, but yeah, anyways, for the first pulse, and this powers, and after a certain amount of delay, this powers. Oh, of course we're going to have these. And it's literally equivalent to doing this. And the second time, this powers, and also this powers. So as we count it before, it's the same timing. So it would just do this, and instead of doing the falling edge, it won't do the falling edge. So it doesn't have the last retraction there. We need to add the extra retraction actually, and that's how we get it to work. We are not going to use the redstone lamp because it is more complicated to get right, to get a toggle and pulses that you need to time at the correct timing. It's quite complicated, and so we're just going to use this technique to replace that. It's the same thing, but with different concepts powering. So as we need the falling edge, we're just going to do this. Okay. This has enough delay. So, and you might be wondering, would this affect this? Well, of course, but this already does its thing for it, so we don't have to worry. Oh, not my mouse freaking out again. I'm sorry. Yeah. So actually, that's our circle done already, and now we're going to do the most impressive part of this door, which is the quad. We have this whole space to do the quad, and you might think that it is actually not that much, but this is already enough for the quad, due to a very clever sequence that I discovered. So we're going to get that now. So I haven't added those powering layouts, but this is the powering layout that I came up with. It's quite complicated, but it is extremely useful. Now, the main concept behind this is this thing here, and this thing here. Let me just build some models of how you can like have this in the door or something. It's just basically this thing. And then if you were to do this, it retracts. And I basically use this concept, and if you see here, it does the same thing again. And this is the basic concept of this, and I basically transformed it such that it can power the quad with a sequence. So the sequence has two generations. The first generation is basically a hopper ROM based timing. So these pulses are going to be controlled by hopper ROMs. So we don't really need to care about the sequence. But you might see just a tiny bit of possible sequencing, and just entire sequence of for the first generation. But uh, when building the store, I realized that placing hopper ROMs is actually quite complicated. And before I attempted to place hopper ROMs, I already discovered the second generation of the sequence. And if you were to look carefully, BAA, this appears one time, BAA second time, BAA third time. Now this has a large potential. Basically, this means that after B, we want to power A twice. And if you were to look closely, this B here is literally, now you can just simulate that, A, B, A. Now, what you see is after B, this is now the B, we can just power A, and it seems to be fine. This means that we can have BAA here as well. Now, this is big news. Basically, we have BAA here, and then BAA here, and BAA here, and BAA here. That's one good news. But what's more good is how we can implement C. So let me just reset this. Now, we notice that C follows with A, and we don't even need a C here. So if we notice one thing is that A is powered first, and if it's powered first, that means that we can have input C here, so we can basically add C here. But if we add C here, that means that this has to be unmovable, and we can absolutely do that. So what we end up last is CA here, BAA, BAA, and repeat the whole process again. CA, BAA, BAA, which is the second generation. So you can see the light blue represents CA, the cyan represents BAA. And if you can see, the sequence is literally this. This here repeated as this here. And this is the second generation. And as I discovered that hopper ROMs are too hard, I started to use like simple circuitry just to get these working. So after discovering the second generation, now it's time to test how we would implement these pulses in. So as I said, CA. So this is CA actually. This thus powers this piston. CA, which is basically A, and then BAA. B is offset from A and C, so we need to do that separately, basically. And to time it, B. Now, we can't do a forward tick like this, because it's too fast. But what we can do, is to use a lamp. And the lamp, as I said, the falling edge has a 2-tick delay. It turns off 2 ticks after. It doesn't turn off instantly. This gives enough amount of delay for the A pulses, the 2 A pulses. Yeah. And we can do BAA again. And due to some later sequencing, this can actually be a standard 4-tick. Yeah. CA now, same thing. B, AA, this has to be a lamp one. and then B, and then we can do the standard phonetic, so AA. Cool. Now it's time to see if it works for the opening. So CA is it. B, A, yeah, B, A, CA, and then B, A, and B, A. Very nice, right? And this is literally the sequence. It's so simple that if you see here, all we need to do is just to fit CA, BAA, and BAA. These two are actually quite different. So one can do a phonetic, a standard phonetic. One can only do a phonetic with a lap. And all we need to do is to fit it in, and to basically have two pulses, two distant pulses. And that also leads to the reason why I decided to use cobweb timers. Cobweb timers are basically just to add delay between. And now we wires. Not that good, and just adding extra A pulses would be slightly better and slightly easier. So now the question is, how are we going to get those cobweb timers? And it's actually quite simple. So yeah, get yourself ready for the minecarts now, because the cobweb timers are here. And don't forget you need fences. Fence posts, I would like to say. So make use of these. These are the ones we're going to make use of. We're going to have a piston here and a piston here. No, here. There you go. Cobwebs are placed here and here. Fences placed here. And then rails. Your minecart, push it. Same thing for here. Push it. Yep. Remember to break this fence post, or it might be you will make yourself a bad day, basically. There you go. You have our minecart set, and now the string. This and this. And we don't really need these now. Bye. Right. So cool. We have our minecart cobweb timers. Now it's time to take the moves. So C. Well, actually, yeah, we can do that later. But C. So the string is here, but we can't redo this. I mean, it is because we need to do this, because the powering layout, if you remember, is like actually this. Oh, also this here must be facing down because it is to update this piston observer. Yeah. Oh, my mouse is literally freaking out. Sorry. So can do that, and we can always do this, but it's not convenient. We need to get to C first before we get to A. And the best way to do it is just to have observer facing down. That's why we would need to zero tick it. And I'm just going to be lazy to use the lever, but some buttons work as fine. So you just have this connected. So this is C and this is A. So move one, this here, done. So CA, we have done it. And then now we need the B. So how are we going to get the B? So this is just with a nice timing, of course, because these are literally timed. You can't do it without timing. And yeah, our snow latch again, using this latch idea to do 2 pulses is actually quite neat. And yeah, now before doing that, I need to place these 2 observers and run a forward tick into it. And you guessed it, we're going to zero tick this here. There we go. And yeah, let's complete this. Cool. Now we got B. We need the 2 A's. So how are we going to get it? Now, again, this is timing. I can't really explain any timings. So, yeah, it's just timed. So, we're just going to have observer chains. One of the simplest thing you can do. And forward tick. And yes, the lamp is here. Lamp, observer, block. So that's going to do the 2 A's for the first BAA. The second BAA though, now we haven't completed this yet, and I said that the latch idea, and yeah, BAA, the second time that how the B goes is literally just finishing this off. Just going to break these, and how to finish this off is quite simple. 2 observers, and it's done. So we already got our second B. This is long, the delay is long enough to get a second B. And now we need 2 A's again, and this time the A can be a forward tick pulse to an observer. And yep, it is a forward tick. So we're going to have forward tick here. Observer, block, then I'm sorry, my mouse is breaking out. Forward tick here. Oh Jesus, why? Don't. Forward tick here. Observer. Oh, sorry. This is more of a version that I remember, but you don't have to. Forward tick and 2 observers. And with that, oh, of course, adding the item into the dropper should be the entire door done. I don't know if I have anything wrong. Yep, let's just see what happens. Oh, I didn't check it. And it seems like it worked. Oh, oh, no. There we go. it works. So yeah, uh, I hope you learned something today. So I hope the explanation would basically explain to you how uh, the concepts of this, like the concepts of this store, uh, some redstone skills maybe, and the power of reusing. Like this door, despite the fact that it's a cave door, it actually reused quite a lot of circuits, and also smart powering layouts basically, like these here. So, and also maybe you might get you might get this how you do sequences. The sequence thing is like the thing and small, and hopefully you would get how you actually do sequences, like how you transform from a completely random sequence into one nice and neat sequence. So, and also I hope you might learn uh, some perfect timing things. Yeah, the racing condition thingy. Yeah. So I hope you learned something for today. And I know this is a very long video, so uh, thanks for watching. If you're still watching to this here, so yeah. Hopefully, my explanation would give you more of a context of how this store works, and maybe uh, you can learn something from it. And yeah, thanks for watching, and I'll see you soon.